Okay, so hopefully you tried this before watching the video. Remember, the more you can work out your brain, the better this stuff is going to stick. If you just watch the videos, you're going to get something, but I want you to really try these, okay? All right, so number 2, hopefully you did these with your buddies on Google Meet, and now you're just checking your work. So what you should have done is write the equation for this reaction. And it says the formation of ammonia. Remember, I asked you to memorize the formula for ammonia. That's NH3. And this says formation of ammonia, so that means this is your product. Okay, so don't put this first. Formation of ammonia from nitrogen gas and hydrogen gas. All right, so we have nitrogen and hydrogen forming ammonia, and we double check. These elements here are diatomic, so we've got to put 2's there. And we're going to go ahead and balance it. 2 nitrogens here means I need a 2 there. 6 hydrogens here mean I need a 3 there. Okay, so that's our balanced equation. Now we're going to draw in here what we actually have. We have 6 molecules of nitrogen. 1, let's do these dark. 1, 2, 3, 4, 5, 6. Okay, and 12 molecules of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's what we're starting with, right? And we want to figure out how much product we can make, and we're going to be making NH3, so that means 1 nitrogen and 3 hydrogens. 1, 2, 3. Okay, 1 nitrogen, 3 hydrogens. 1 nitrogen, 3 hydrogens. And another nitrogen, 3 hydrogens. And another nitrogen, 3 hydrogens. And another nitrogen, 3 hydrogens. Another nitrogen, 3 hydrogens. And the last one, nitrogen, 3 hydrogens. And I am out of nitrogen. And I'm out of hydrogen, and now I have 2 of those left over, so I gotta draw them there because they're still there. Okay, so this is what it looked like before, that's what it looked like after, and we can answer these now. How many molecules of ammonia produce? 1, 2, 3, 4, 5, 6, 7, 8. Which reactant is in excess? These are my nitrogens. Why? Ran out of hydrogens. Okay, how many molecules of excess reactant are there? 2. Okay, so that's the picture conceptually of what's happening, and now we're going to do this, but we're going to do this as if we didn't draw this, as if we didn't know the answer, and then we're going to compare them. Okay, so my balanced equation is here. And I'm writing my starting amounts, which were, we had 6 of these, and we had 12 of these, and none of this in the beginning. Okay, so let's pretend that we think that nitrogen is our limiting reactant. Okay, so if you didn't draw it, you wouldn't have known that nitrogen is the excess reactant. So let's pretend that we think, okay, we're going to test this out. If this is my limiting reactant, then everything else is going to be determined from it. So now I'm going to use my coefficients here to figure out how much of the other stuff is getting used up or made. So if this is a 3-to-1 ratio, that means this one is going to be 3 times greater than that. So 3 times 6 is 18. Okay, so I look at it and I see, oh, that won't work. I can't use up 18 molecules of hydrogen because I only have 12. Therefore, this is not my limiting reactant. It's got to be the other one. So I'm going to do that one instead. So if I use up all 12 of these, and I use look at my mole ratio, this is a 1-to-3 ratio, so this is 1/3 of that. So if I wanted to see how that looked, here it'd be 12 moles of H2, okay, and it's want over have, so I want N2, it's only one of those, I have that, 3 H2s, so that means I'm going to take this 12 divided by 3, which means it's 4. Going to use up 4 of those, and I can, right? Because I have 6, so that's plenty. So that means I am going to have 2 of these left over and use up all of that. And I'm going to use the ratio again to find my product. So this is my limiting reactant. This is the right one to use to figure out my product. So 12 moles of H2. And this is my want this time, want over have. So 2 NH3s over 3 H2. So it's going to be 12 times 2, which is 24, divided by 3, which is 8. So I'm going to be making 8 of those, and I'll have 8 at the end. So let's check that with what we figured out with our drawing. Okay, I have 8 molecules of ammonia produced, yes. Which is my excess reactant, N2, yes. And how many of it do I have? 2, yes. Okay, so when you're doing these limiting reactant type problems, you do a test to see which one is actually the limiting reactant. Remember, you can only use up what you actually have. And if by choosing one reactant, it turns out that you're using it more than you have, that means the one that you started with is not your limiting reactant. You got to switch them. Okay, so let's just finish answering these questions here. According to the table we just made, how many molecules of ammonia can be produced? 8, just like above. Which reactant is in excess? The one that has stuff left over at the end. N2, and how many? 2. Okay. All right. So you have your assignment. What you're going to turn in is you're going to answer the question or make a summary. So this is the first page of that worksheet I gave you. You're going to write a summary and reflection of this. Describe what you must look for in a particular reactant mixture to decide which reactant will be in excess. Okay, so you're going to answer these 2 questions on a separate document and turn that in. All right. Thank you, guys.